This video will look at the answers to the assignment questions, Mathematics of Chemical Formulas 1. So in this problem set, we're looking at some of the basic arithmetic associated with chemical formulas before we move any further with the mathematics. First thing that we want to do is determine the formula mass of nitric acid. And to determine the formula mass of nitric acid, we need the formula for nitric acid. The formula for nitric acid is going to be hydrogen combined with the polyatomic ion nitrate. This does not begin with hydro, so it is a ternary acid or hydrogen with a polyatomic ion. Since it ends in IC, our polyatomic ion is nitrate. Nitrate has a -1 oxidation state or charge. Hydrogen has a +1. So this is going to unite to make for 1 hydrogen for every 1 nitrate. So once we find the formula, we then know that we have in the formula 1 atom of hydrogen, 1 atom nitrogen, and 1 atom, make that 3 atoms of oxygen. We then convert atoms to mass. So we have atoms, then we go to mass. To do this conversion, we need a relationship between a number of atoms and a mass. For formula mass, the mass is in AMU. We can find on the periodic table by looking at the average atomic mass that on average every atom of hydrogen, every 1 atom, is about 1.01 AMUs. This gives us 1 times 1.01 is 1.01 AMUs. Atoms cancel. We repeat for nitrogen. Every 1 atom of nitrogen has a mass of approximately 14 AMUs. That gives us 14.0 AMUs contributed by nitrogen. And then the contribution to the total mass by oxygen is going to be around 16 AMUs per 1 atom of oxygen. It's going to be 3 times 16 would be 48 AMUs. The total mass then is the sum of these three. Hydrogen's mass plus nitrogen's mass plus oxygen's mass. That sums up to 63.01 AMUs. And we could probably actually write that to just 63.0 AMUs as our final answer. The next formula would be potassium arsenate. Potassium is K with a +1. Arsenate is ASO4 with a -3 charge. This is going to give us, we've got a +1 here. We do our crisscrossing method. Arsenate in parentheses, 3 there. That gives us K3 and 1 ASO4. Since we only have one of these, a 1 out here, we leave the parentheses out. This gives us 3 atoms potassium, 1 atom arsenic, and 4 atoms of oxygen. Every 1 atom of potassium is 39.1 AMU. Every 1 atom of arsenic is 74.9 AMU. And then for our oxygen, for every 1 atom of oxygen, we have 16 AMU of oxygen. So this is 3 times 39.1 is 117.3 AMU. 1 times 74.9 is just 74.9 AMU. and 4 times 16 would be 64 AMU. Find the sum of those three values is 256.2 AMUs total. Final answer. Copper 2 chloride. For this formula we have copper with a positive 2 oxidation state and chloride with a negative 1 charge. This is going to give us, if we combine, for every 1 copper we're going to have 2 chlorine to give CuCl2. That gives us, from this formula, that gives us 1 atom copper, 2 atoms chloride, every 1 atom of copper, 63.5 grams, AMU, and for every 1 atom or 1 chloride ion, we're at 35.5 AMUs. This gives 1 times 63.5 is 63.5 AMU, and 2 times 35.5 is 71.0 AMU. And that gives us a sum, add them together, of 134.5 AMU. Alright, next we want to move to molar mass. The difference between molar mass and formula mass is that with molar mass we're considering a mole of particles instead of individual particles. So with sulfur dioxide, instead of having 1 molecule of sulfur dioxide, we have 1 mole of SO2. Sulfur dioxide is covalent, no prefix for sulfur, so that's 1 sulfur dioxide, 2 oxygens. So in 1 mole of SO2, keep in mind if we were dealing with molecules, this would be 1 molecule, but this is a mole of molecules. So in 1 mole of SO2, we have 1 mole of S, and we have 2 moles of O. We want to know the mass. So this is the mass of 1 mole, so this is also going to be the sum total. So we would have, for every 1 mole of sulfur, of 32.1 grams. So an individual atom of sulfur is 32 AMUs, but a mole of sulfur, 32.1 grams. That gives 1 mole cancel, and that gives us 32.1 grams from sulfur. And then for every 1 mole of oxygen, notice that we're always using 1 mole in these conversions, we're going to have 16 grams. That's going to give us 16 times 2 is 32 grams of oxygen. We then sum the two together to give 64.1 grams of SO2. And I'm saying 64.1 grams here, but technically, since that was 1 mole of SO2, this is 64.1 grams for every 1 mole, or grams per mole. Okay. Next, we want to determine the molar mass of aluminum hydroxide. Aluminum hydroxide is going to be a combination of Al and hydroxide. This is going to give a combination of AlOH3. So we're going to have, in 1 mole of this, if I put a 1 out here, that means 1 mole of aluminum hydroxide. We're going to have 1 mole of aluminum and 3 moles of oxygen and 3 moles of hydrogen. There are 3 here distributing through the parentheses. Okay, so 1 mole of aluminum is going to be 27 grams in every 1 mole of aluminum. We're going to have 16 grams in every 1 mole of oxygen. And we're going to have 1.01 grams for every 1 mole of hydrogen. Our moles of aluminum cancel. That gives us 27 grams of aluminum, 48 grams of oxygen. That's 3 times 16 would be 48. And then we have 3 times 1.01, and that's going to be 3.03 grams of hydrogen. We then add those together, and we end up with a mass of, let's see, 78.03 grams per mole AlOH3. And you could very easily just put that as 78.0 grams. Okay, our last of this type problem is iron 2 dichromate. But this is a typo. This is actually supposed to be iron 3. So let me change that right now. Another number there. This is iron 3 dichromate. And we need a formula for that. Iron 3 dichromate is composed of iron 3, or iron with a positive 3 oxidation state, and dichromate, Cr2O7 with a negative 2 charge. So we're going to crisscross our oxidation numbers, give 3 down here, and 2 over here. That gives Fe2 Cr2O7 3. So as we're sorting this out, we have 2 moles of Fe. We have 3 times 2 would be 6 moles of chromium. And then we have 3 times 7 would be 21 moles of oxygen. We do our conversion. It's 55.8 grams for every 1 mole of iron. There's 52 grams for every 1 mole of chromium. And then, as always, there's 16 grams for every 1 mole of oxygen. So this is going to be 111.6 with moles of iron canceling. That's grams, specifically of iron. We've got 312 grams of chromium. This is grams Fe, this is grams chromium. And then this one is going to be 21 times 16 is 336 grams of oxygen. We then sum them together, and that gives us 759.6 grams per mole of this compound. All right, in our next problem, we're going to utilize the molar mass to help us calculate some more basic arithmetic, converting between mass and number of particles and moles. All right, so we want to calculate the mass of 4.5 moles of strontium chloride. whenever we're calculating masses of moles worth of particles, these masses are going to be in grams. So whenever you see mass, unless you're told otherwise, consider mass to be in grams. So we're given, if you'll remember in factorial label or dimensional analysis, we have a given multiplied by a conversion factor, and that equals the desired answer. So in this case, our given is 4.5 moles of strontium chloride. Strontium is a positive 2, chloride is a negative 1, so this is going to give SrCl2. We want to know the mass per number of moles. What we have to find here is the mass of 1 mole and then multiply it by 4.5. So 1 mole of strontium chloride, SrCl2, has 1 mole of Sr and 2 moles Cl, just looking at the subscripts. Every 1 mole of Sr has a mass of 87.6 grams, and every 1 mole of chlorine is 35.5. Okay. If we add these together, after we do the calculations, what we find is that we've got a mass of 158.6 grams per mole of SrCl2. So that 158.6 grams would go here. So this is just the sum total of the two answers here, which would be, I should have actually wrote it down just in case. So this is 1 times 87.6 is 87.6 grams. 2 times 35.5 is 71 grams. And that gives us our 158.6 grams. So we're using our molar mass and the conversion factor. In fact, it is the conversion factor. Moles cancel. You get 4.5 times 158.6 gives 713.7 grams SrCl2. Next problem, we have, we want to know the number of moles in 3.4 grams of sodium hydroxide. Okay, so we're given 3.4 grams sodium hydroxide. That's Na plus 1, OH minus 1. So that's going to be NaOH. We want to know a number of moles. So we want mole in our numerator, and we want to cancel grams. For sodium hydroxide, we've got 1 mole Na, we've got 1 mole oxygen, and we've got 1 mole hydrogen. It's 23 grams for every 1 mole of sodium. 16 grams for every 1 mole of oxygen, and then there's 1.01 grams for every 1 mole of hydrogen. This gives us 23 grams sodium, 16 grams oxygen, and 1.01 grams of hydrogen. Add these together and we get 40.01 grams. So in every 1 mole, there's 40.01 grams. Grams canceling, and our answer would be 3.4 times 1, and then that answer divided by 40.01. Or just 3.4 divided by 40.01, and that gives us 0.0850 moles NaOH. In C, we're going to want to calculate the number of formula units in 16.2 grams of silver chloride. Let's start with silver chloride. Silver, +1, chloride, -1, so that gives AgCl. Now, we want to know the number of formula units in 16.2 grams given of AgCl. This is an ionic compound, and a formula unit is the simplest particle in an ionic compound. So if this were a covalent compound, we would replace the word formula units with molecules, and they'd be the same thing. We handle them exactly the same way. So with silver chloride, we want to know how many formula units in 16.2 grams. So we need to cancel mass and go to units. Mass is always going to come from the molar mass. So that's going to be in a mole of silver chloride, we have 1 mole Ag. It's 108 grams for every 1 mole. It's 108 grams from silver. And then from chloride, we have 1 mole Cl. It's 35.5 grams for every 1 mole. Equals 35.5 grams Cl. So that gives us a sum total of 143.5 grams per mole of AgCl. So we have 143.5 grams, and we also know that 1 mole equals 6.022 times, or 23, times 10 to the 23rd formula units. 1 mole is that many particles. So we use Avogadro's number. Grams cancel. We have 16.2 times Avogadro's number, and then that answer divided by 143.5, and that gives 2.60 times 10 to the 22nd formula units. Okay, problem D. We want to know the number of molecules in 260 grams of carbon tetrachloride. Carbon tetrachloride is a covalent compound. It's using Greek prefixes, so 1 carbon, 4 chlorine, CCl4. We have 260 grams CCl4. And we want to know a number of molecules. To find that, we have to cancel gram and go to molecules. Whenever we have particles, we always are going to put 6.023 times 10 to the 23rd in the conversion factor involving molecules. Mass comes from adding up the molar mass of the compound. So we have 1 mole carbon, and we have 4 moles chlorine. There's 12 grams for every 1 mole of carbon. And there's 35.5 grams for every 1 mole of chlorine. So this is going to be 12 grams from carbon and 142 grams there. Add those together and we get 154 gram per mole of carbon tetrachloride. Keep in mind that 1 mole equals 6.023 times 10 to the 23rd molecules. So our mass, 154 grams, goes here. Grams cancel. We multiply 260 times Avogadro's number and then divide that answer by 154, and that gives us 1.02 times 10 to the 24th. And the final unit would be molecules. CCl4. Problem D. We want to know the mass of a certain number of molecules of silicon dioxide. And likewise, this is also covalent with 1 silicon, 2 oxygen. So we have 2.6 times 10 to the 24th molecules SiO2. We want to end up with a mass in grams SiO2. So we know that we're going to have a molar mass of SiO2 from the periodic table, and this is going to be molecules. And that's always going to be Avogadro's number. We have 1 mole of Si. We have 2 moles of oxygen. Every 1 mole of Si is 28.1 grams. That gives 28.1 grams of Si. And then we've got, for every 1 mole of oxygen, we've got 16 grams. That gives 16 times 2 is 32 grams oxygen. Sum those, and we get 60.1 per mole. So that means we have 60.1 grams per 6.022 times 10 to the 23rd molecules. And we multiply 2.6 times 10 to the 24th by 60.1, then divide that answer by Avogadro's number, and we get 259.4 grams of SiO2. In our last problem, we want to know the number of molecules in 14 grams of ammonia. Now, ammonia is one of those molecules like water that we go with a traditional name that takes precedent over any chemical system. Ammonia is NH3. That is a molecule that you should know the formula of, just like you know water is H2O. So we have 14 grams NH3, and we want to know how many molecules. All right, we're going to then put molecules in numerator, mass of NH3 in denominator. We know this is going to be 6.023 times 10 to the 23rd molecules, and we have 1 mole nitrogen plus 3 moles hydrogen. Every 1 mole nitrogen is 14 grams. Every 1 mole hydrogen is 1.01 grams. Gives us 14 grams of nitrogen and 3.03 grams of hydrogen. 14 plus 3 is 17.03 grams per mole of NH3, or 17.0 would be fine. So we've got 14 times Avogadro's number divided by 17, and that gives us 4.96 times 10 to the 23rd molecules.